A lot of this decision comes down to AC and DC losses, right? So we found that DC voltage drop and DC losses are less expensive than AC voltage drop. So a few years ago, it kind of almost lined up perfectly with the advent of the 1500 volt DC string inverters that it made the most sense to design these as virtual central or cluster them at the main equipment pad, just because running DC at 1500 volts back to your pad was less expensive than running 480 or 600 volt AC throughout your system to a main equipment pad. The DC losses are not linear to your production, as AC losses are definitely linear. As you lose AC power, you lose production. So um, most sites, for that reason, we've moved to virtual central design, clustering them at the pad.
With the distances, the other thing we keep in mind is, the difference between running three-phase AC and DC PV. In addition to having the higher voltage, you also have less conductors. So that adds up to why it typically makes sense to try to run those on DC. And then we often utilize above ground cab systems or above ground wire management systems where possible. And we've done it both ways, where we populate like a DC combiner box along a cab run, or are running all of the DC strings back to the centralized PV or the string inverter station. Kind of depends on the distances and the layout of the site. Some of the new code has made it a little more restrictive with the number of circuits that can be in any one hanger or conduit. So that's where lately we've gravitated a little bit more towards using the DC combiner boxes. In fact, I've even had projects where it's been a combination of some DC combiner boxes, some not, just really based on the distance of that string in relation to the endpoint or where the inverter is located. And then with that, it is convenient, I think, from an O&M perspective, to have all those inverters populated in a central location. Your AC runs then are pretty minimal. You end up with less excavation that has to occur to get to the switchgear. I think there's a number of advantages there, but yeah, that's been our historical, kind of lens on that. And we have done central inverters as well with DC combiners throughout the field. Really the central inverter, if there is any advantage, it would be just there's less equipment. So you bypass the need for a switchgear. Typically, the central inverter is coupled to the step-up transformer. So there's been some cost savings with that, but at the systems that we're typically working, the system size that we're typically working in, that minimal savings is probably irrelevant to the long-term performance of the site if you ever had one instance of a failure.